Okay, Delia, you asked why the Japanese method of multiplying works, the lines method. So I figured I would try to make a quick video to figure that out and explain it while I'm figuring it out because I actually haven't thought about it in a while, but I know it reveals itself when we look at it. So let's think about what these lines mean. So I think the way you do it is for every digit, you draw a set of lines in one direction that represents the digit for that number. And the lines are all parallel for the digits in the numbers. And then you draw um, lines that are perpendicular to those lines for the digits in the other numbers. So if we have, so let's see, 1 times 0 would be one line like this, because this first number has one digit, and so you draw one line for that single digit, and that digit is 1, so that's why there's one line. But there's also one group of lines because there's only one digit. Okay, and then in the other direction you have 0 lines. You have 0. Yeah, you have one group of 0 lines, so we haven't drawn any lines. And then to get the product, you just count up the number of times the lines have been crossed. So there's no crosses to count, so the answer is 0. So, okay. So if it's 1 times 1, then you would have 1 line crossing, and now you see you have one place it crosses, so that equals 1. So let's take a look at 2 times 1 means rewrite 2 lines in this direction. It doesn't matter what direction you start out with as long as you're consistent within each problem. So 2 times 1 is 1, 2. So you can see why this works with single digits right away, because if you have, with 1 at least, well, with 0 is easy. 0, there's never going to be any line crosses. So everything times 0 is going to be 0. So everything times 1 is going to be 1 because you're going to draw a certain number of lines, and then you're going to count the places they cross. So one line is going to cross 2 lines in 2 places. That's just the way that works. So so that's 2 times 1 is 2. Okay, so going to the slightly more complicated example, we'll add a second digit in here. We'll say 22 times 1. And the way they do this is for each, like I said, for each place, they do a different group of lines. And so this is 22 times 1. 22 times 1. And now we don't just count up. So here's where this, I guess, one of the secrets in how this works is that we don't just count up all the places they cross. We don't say 1, 2, 3, 4. And that would be wrong, right? 4 would be wrong. We count the places. So so when we have different groups, just like these digits are represented by these groups, the different groups are going to be represented by the different groups are going to represent different digits in the answer. So 1, 2 and 1, 2 is 22. And if we change this to a 2, then of course we put another, so there's still the same single digit there, but now it's 2. And now it's, the answer is 4, and that's 4. Okay, so why is it 4 and 4? Well, if you ignore the other group and focus on a single group, you're always multiplying one digit by another digit. And by keeping track of how many of what place it is, so this is the tens place because we're going by, this is 10, this is 10 twos or two tens, right? 10 twos is two tens, but this is two tens and this is two ones. And we are just counting the number of times that it crosses the two. So 4 tens and 4 ones is 44. Previously, it was 2 tens and 2 ones. So the place value system is preserved in here just by the position of where the groups cross. So what about if we make it the slightly more complicated example again and make it 22 times 22? So what they do now is they group it by they additionally add. So we obviously we have I guess this becomes the tens place. This becomes the ones place of the other digit of the other number. This is the tens and this is the ones. But now we start looking at where these things line up. So if we've got 4 here, we count 4, and then we count 8 here. We've got 4 there and 4 there. 8. And then we've got 4 here. So that's 4. So 22 times 22 is 484. Well, how do we do 22 times 22 with the standard algorithm? We say 22 times 22. Like this, right? And the way we do this is we say 2 times 2 is 4. And then 2 times 2 is 4. Notice that we never did any multi-digit multiplication there. We just multiplied this digit times this digit, and we just wrote it down here because that's what the algorithm tells us to do. And then we multiplied another digit by another digit, and we just wrote it down here. And that's because that's what the algorithm told us to do. Okay. So the equivalent of multiplying one digit by this 2-digit number over here is the same as writing a 4 here and a 4 here. So that's 44. And so you can kind of think about that as ignoring these 2 lines and just looking at these 2 lines, right? So that's 4 there and 4 there. So now when we do the next digit in the bottom 22, we multiply 2 times 2, and we've learned to write that here as 4. But to understand how this works, this is not 2, but this is actually 20. This is 2 tens. So 2 tens times 2 is actually 40. We learned to write it over to the left a little bit. It's really 40. So we really just wrote 40. And then 2 tens times 2 tens is 400. But because of the way the algorithm works, we've learned to just write it here. So we just added 400 to 40. That's one way to look at it, but we don't talk about it that way when we teach it. Well, at least when I learned it, we didn't talk about it that way. We just learned to write the digit here. And so there was no addition going on when we write the digit. But when you think about how it works, you are adding 400 to 40. You're not just writing a 4 to the left of a 4. It works without using addition because of the place value system, as long as you just write things in the correct places. So what's going on over here? Well, it turns out that if this was the ones place, and this was the tens place and the ones place, then this is the tens place being multiplied by a ones place and a tens place. So you get a 4 there, and then you get a 4 here. But this, again, because it's a tens times a 1, is really a 40. And this is really a 400. And we don't actually add them together. Well, we kind of add them together because we write them as we're counting them. We write them over here. This is 4. do it backwards. And then we have to add these, or we just count them all. And that's just like adding 4 and 4, and you get 8. Whoop. And then this 4 is counting how many hundreds we ended up with, and that turns out to be 4 hundreds. So in a lot of these cases, we are just writing things in the correct place, which takes the place of adding those things together, because these methods allow us to separate the different places. Because we are separating them, we never have to do the adding, because the adding is done for us, because by writing them in the right place and combining them, you do the equivalent of addition. I think this makes sense to you as long as you understand that these crosses, mean a 4 times 4. I'm sorry, 2 times 2. And this is 20 times 2. I'm sorry, this is 2 times 20, and this is 20 times 2, and then this is 20 times 20. I hope I said that right. Does that make more sense? I hope so. I hope it shows that these methods are actually the exact same thing, but one is being done with digits, and the other is being done with lines that you then count and turn into digits.